Hello, my name is Asher, and this is an explanation on how to solve homework problem 16.14. We are given a picture of a history graph of a wave at x equals 0 meters. The wave is stated as traveling left at 2.0 meters per second. Our first question is, what is the amplitude of the wave? The amplitude of a wave is the height of half of the wave from the center line to one of its peaks. So from right along here, this is the center line in this case, because we can see that the wave oscillates between -6 and 6, which means that the middle is at d equals 0 centimeters right there. So in this case, the distance from the center line to one of its peaks right here is 6 centimeters. There we go. Therefore, the amplitude is 6 centimeters, so I will write that there in the top corner. Alright, our second question asks, what is the frequency of this wave? We can find the frequency of the wave by dividing 1 by the period of the wave. So that equation is frequency equals 1 over t period. To find the period, we can measure the distance it takes for the wave to start repeating itself. In this case, I will choose to measure from this point right there, and I'll look along this wave to see where it starts repeating itself, which is right here, because it's going up here, it's going up here. So right here, this distance between this first point and this second point is going to be the period. So t equals 0.8, that's an 8, we'll pretend that's an 8, minus 0.2, which is equal to 0.6 seconds. Gotta remember those units, seconds. So if we know that t equals 0.6 seconds, then we know that, I'm going to rewrite this, that frequency is 1 over 0.6, which is equal to 1.67 hertz. There we go. Alright, our third question asks, what is the wavelength of this wave? Now you may wonder why the wavelength is not 0.6 seconds, being that the wavelength is similar to the period. However, this is a history graph which measures the location of one individual point of the wave, which in this case is the point at x equals 0 meters. So 0.6 as the period measures the amount of time it takes for that single point to complete one cycle. But what we want is the wavelength, which is based on the snapshot graph, which is a graph showing how the entire wave looks at one individual second. Therefore, wavelength is a measurement of the length of a wave, while the period is a measurement of how long it takes one part of a wave to repeat itself. Now, we aren't given the snapshot graph, but what we are given is the information that the wave is traveling left at 2 meters per second. We also recently learned that wavelength, lambda, equals velocity over frequency. So we have velocity right there, we have frequency right here, so we can put those together in the equation to solve for our wavelength. So lambda equals 2 over 1.67, which is equal to about 1.2 meters. Therefore, we know wavelength equals 1.2 meters. And this makes logical sense as to why this is the wavelength, because we know that it takes one point on the graph, 0.6 seconds, to completely oscillate back to where it began, right here. And we know that the wave is traveling left at 2 meters per second. So in order to find how long the wavelength is, we could also just multiply 2 meters per second by 0.6 seconds, which is going to give us the total wavelength, the total distance that one point has to move, which is 1.2 meters. And it's important to note that this point does not actually move, because the point at x equals 0 meters stays at x equals 0 meters forever. It just goes up and down with the oscillation of the wave. However, you can use this period to measure the wavelength because that measures the distance from one point in the little dip thing here to the other point in the dip right here. So this equation still works out.